Hello class, this is a video tutorial on using a table of values, and this is just a continuation of the video where first we showed how to do it for algebraic expressions. When we saw how all we did was create a table where along the top row we have the variable or the letter which is present, and along the bottom row is the full expression that we saw. So when it's x plus 1, it belongs in the second row here. So same case here, we have x as the variable, or the pronumeral, and along the bottom row will be the expression. So if the full expression is 2x, we got 2x there. And all we did to find the values along the bottom row is that we substituted the number along the top row into the expression to get the result. And I demonstrated here that you can do it by hand, or you can do it in your mind. So how I got this answer is by taking the expression x plus 1, substituting the value in the column. So in this column it's -3, so we substitute -3 into the expression. So we get -3 plus 1. We evaluate that, so -3 plus 1 equals -2, hence why -2 belongs in that row, or in that box, sorry. So for example, this value here of 2, we obtained that by substituting the value of 1 into the expression x plus 1. And if you can calculate in your mind, it'll be 1 plus 1 equals 2. Now, for this video, we're going to see how to do the same thing, but only with an equation. It works very similar in that along the top row, we take whatever variable is on the right hand side, often the one on its own, just like that there. Oh, sorry, not the one on its own, the one that's in the algebraic expression. And the one on its own, which as we've seen in previous videos, is the subject. Since this is the subject, we place that along the bottom row. And it works very much the same. We substitute values from this column into the letter that it represents, and we get a result for that, for the subject. So in this first column, all I did was I substituted -3. So y equals -3, which was supposed to be x, but is now -3 because we substituted. -3 plus 3 gives us 0. Here we also have y equals -2, which remember is supposed to be the x, but since we've substituted -2, it is now y equals -2 plus 3, which is -1. Oh, sorry, +1. And then we can do the rest in our minds, and we do that merely by just calculating mentally. So let's do that together now. Let's substitute the value of -1 into this expression. Y equals -1 plus 3. -1 plus 3 is 2. Let's substitute the value of 0. Y equals 0 plus 3. 0 plus 3 is 3. And as you can already see, there's a pattern emerging here. 0, 1, 2, 3. And I'm certain the next one will be 4. But let's test that anyway. Y equals x, which is now going to be 1. We're substituting 1 here. 1 plus 3 is 4. And there is our pattern emerging. 0, 1, 2, 3, 4, 5, and 6. And I'm sure if we extended this table of values either way, it would still follow the pattern. So when x is 4, y will be 7, and so on. Now let's do one for this expression, y over 2, which is x divided by 2. So once again, the variable in the expression belongs here, and the subject on its own belongs along the bottom row. For this, since I know it's a half, I'm only going to pick even numbers. I know I said it's best to use numbers increasing by 1, but you'll see that by picking even numbers, so we'll start at negative 4, negative 2, 0, 2, 4, 6, 8. You'll see that it'll give us a far better and much easier to calculate pattern. Let's do this here. Let's do this mentally. Y equals negative 4 divided by 2. Negative 4 divided by 2 is negative 2. Let's substitute the value of negative 2. So y equals negative 2 over 2. Negative 2 divided by 2 is negative 1. Substituting 0, y equals 0 over 2 is 0. Y equals 2, so 2 over 2 is now 1. And can you yet see the pattern? Let's test it again. Y equals 4 over 2. 4 divided by 2 is 2. Negative 2, negative 1, 0, 1, 2, 3, and 4. Let's move along here. Now, it may seem confusing because now we're just using different letters, but it's essentially still the same. The subject belongs on the bottom row, and the variable, the one inside the expression, belongs in the top row. And once again, you can pick any value that you like. I'll begin, just to make it simple, from 0 onward. 0, 1, 2, 3, 4, 5, and 6. Substituting our values. A equals 2 times B, which is now going to be 0. In case you can't see that, it will be A equals 2 times 0 minus 1. 2 times 0 is 0 minus 1, negative 1. Substituting the value of 1, so A equals 2 times, substituting 1 for the value of B, minus 1. 2 times 1 is 2, subtracted by 1. 2 minus 1 is 1. That's why that belongs there. We'll do one more, just so that we can see the pattern. It'll be A equals 2 times 2, which is the value we are now, minus 1. 2 times 2 is 4 minus 1, which is equal to 3. Negative 1, 1, 3, that's going up by 2's, so the next one will be 5, 7, 9, 11. We'll do one last one here. And for this one, now we have just same expressions, different letters. So the variable t, the one with the expression, belongs in the top row. And along the bottom row is the subject, which is A on its own. And once again, I'll go back to my classic negative 3, negative 2, negative 1, 0, 1, 2, 3. These are the values that I tend to always go back to. Now for this, what we're going to be using is a calculator, because that is much easier to do, because we have a strange number to multiply by here, which is 3.3. So let me go grab my calculator. Here we are. let's just use my digital calculator here just to make it easy to see on the screen. I found that it was rather difficult to try and grab it from my regular calculator. So let's try it here. It'll be 3.3 times -3 plus 2. That will give us -7.9. Substituting the next value, instead of -3, we have -2. We get -4.6. Substituting -1 gives us -1.3. Substituting the value of 0, because that's where we are now. Where we are now here. So 3.3 times 0 plus 2 gives us +2. Substituting the value of 1 gets us 5.3. Substituting the value of 2, 8.6. And the value of 3, x equals 3, gets us the value of 11.9. So I hope this is insightful into how to use a table of values to substitute for either an algebraic expression or an equation. Best of luck.